Assalamu alaikum. Hello everyone. Today we start our next topic, introduction to integrated circuits, ICs, IC and logic families. IC, also known as chip, microchip, microelectronic circuit, is an assembly of electronic components fabricated as a single unit in which miniaturized active devices, transistors and diodes, and passive devices, capacitors and resistors, and their interconnections are built up on a thin substrate of semiconductor material, usually silicon. The resulting circuit is thus a small monolithic chip which may be as small as a few square centimeters or only a few square millimeters. The individual circuit components are generally microscopic in size. ICs are classified according to degree of integration. Degree of integration is defined as the number of electronic components contained in the chip. Contained in the chip. This number is called degree of integration. According to degree of integration, ICs are classified into small scale integration, 10 to hundreds of transistors per one chip, medium scale integration, hundreds to thousands of transistors per chip, large scale integration, thousands to several hundred thousand transistors per chip, very large scale integration, VLSI, up to 1 million transistors per chip, and ultra large scale integration. This represents a modern IC with millions and billions of transistors per chip. This table is from Wikipedia. Small scale integration starts in 1964. They were used in the mainframe IBM 360, the start of the third generation computers. Medium scale integration, they were produced in 1968 and they were used in the mainframe IBM 370, the start of the fourth generation computers. I already said the number of transistors in each of these parts. Large scale integration, they started in 1971, very large 1980, and ultra large scale integration, they contain millions and even billions of transistors per one chip. They start in 1984. These are some ICs, just to take a look. There are two main advantages of ICs over discrete circuits. The first is cost and the second performance. Cost is low because the chips with all their components are printed as a unit by photolithography rather than being constructed one transistor at a time. Furthermore, packaged ICs use much less material than discrete circuits. Performance is high because the IC's components switch quickly and consume relatively little less power because of their small size and proximity. However, the main disadvantage of ICs is the high cost to design them and fabricate the required photomasks. This initial cost means ICs are only commercially feasible when high production volumes are anticipated. This is an example of one IC from the 74 series, a 4-bit adder used to add a 4-bit number, for example, number A and number B. Number A, 4 bits, A4, A3, A2, A1, and B, B4, B3, B2, B1, and generates S1, the sum S2, S3, S4. There is a carry out and the carry in usually is a control signal because this IC is used as adder subtractor. This is A, 4 bits, B, 4 bits. This is the sum, the control C, and the carry out. So as you see, we have 16 pins, 4 pins A, 4 pins B, 4 pins for the sum, 4 pins, carry control signal or carry in and carry out, 2 pins. This is 14. We have additional 2 pins, one for ground and one for power supply. Usually this circuit, the external power supply is 7.5 volt and internally it consumes 5.5 volts. Really, why adder subtractor? Do you see this carry as a control signal? We will design this circuit later, and if it's 0, add, and if it's 1, subtract. If it's 0, here no change, and the M is exclusive or with all bits with B. So no change, A will be added to B as usual. However, if it's one exclusive or any bit in BI, means that we complement this bit. And addition of 1 here, we obtain the 2's complement. This means that we are adding A with 2's complement of B. And this is equivalent to A minus B in case of the control 1. If it is 0, then nothing is changed and we add A to B. As we move in the course, we'll be familiar with more ICs ready to use. Digital integrated circuits are classified not only by their complexity or logical operation, but also by the specific circuit technology to which they belong. This circuit technology is referred to as a digital logic family. Each logic family has its own basic electronic circuit upon which more complex digital circuits and components are developed. The basic circuit in each technology is NAND, NOR, and inverter. The electronic components used in the construction of the basic circuit are usually used as the name of the technology. The main characteristics of logic families include speed, fan-in, the number of inputs the logic gate can handle, fan-out, the number of outputs that a gate can drive, noise, immunity, power dissipation. By speed of a logic circuit is determined by the time between the application of input and change in the output of the circuit. Noise immunity, maximum noise that a circuit can withstand without affecting the output. Power, when a circuit switches from one state to the other, power dissipates. The most popular logic families are TTL, transistor logic, ECL, emitter coupled logic, MOS, metal oxide semiconductor, and complementary MOS, complementary metal oxide semiconductor. TTL really was developed from DTL, diode transistor logic, and the widespread logic family that has been in operation for some time and is considered as a standard. ECL, emitter coupled logic, has an advantage in systems requiring high speed. MOS and CMOS are the most common used and most suitable for circuits that need high component density. And complementary MOS is preferable in systems requiring low power consumption. For today, thank you.